Good morning, everyone. I'm Marius Papafemio. I'm the chair for Computer Science and Engineering. It's an honor and a pleasure for me to introduce the first speaker of the workshop, Usama Fayyad. Usama is no stranger to UOM. He got his PhD from UOM 2 decades ago. He started working on big data and data analytics before, long time before big data and data analytics became household terms. Currently, he's the Chief Data Officer at Barclays in London. He has started and contributed to numerous startups, most notably the DMX group, which he led in the early 2000s, was acquired by Yahoo in 2004. He was the Chief Data Officer at Yahoo until 2006. And I think he has a very fascinating presentation. I should let Usama do all the talking. Usama.
Thank you, Mario. I apologize, everyone, because bad planning on my part. I have a 12 o'clock flight to catch, so we'll see what happens there. 10 days ago, I missed the first flight of my life. It was Seattle to London. So I don't want to repeat that, but this one's only San Francisco. Okay. So what I'm going to talk about is going to be a little different and on purpose. I really don't want this to be academic and technical, although I think at its core it is technical, because all of these problems I'm going to talk about are technical problems. But they manifest themselves in very practical ways and very real pains for companies, for banks, for telcos, for insurance companies, you pick it, healthcare, everywhere, government, if you wish. I'm not going to talk much about the Chief Data Officer role here, especially since we don't have time, because I want to focus on the other stuff, which is really, my focus is about big data, not necessarily data mining. I'll talk some about data science. And I'm going to give you my goal would be to give you the industry view, even though I am pretty heavily involved in academics, and up until last year I was the chairman of the ACM SIG-KDD, which is a special interest group on data mining. We run a pretty big conference on the topic every year. That's now up to like 1,200 attendees. So the area is picking up. And I'll use case studies to illustrate some of these things. You guys know this. You know, what matters is what value can you get out of data? How do you get people to use the analytics? Because nobody really wakes up out of bed and says, I really want to look at the data, right? They wake up and say, I have to solve a problem. And that problem typically has a business or scientific value or what have you. My first experience in data mining, actually with my PhD thesis from U of M, I went to NASA, JPL, applied it to things like astronomy, planetary geology, Earth observing systems, and I was amazed at how much traction it got and how much need it had in the scientific community, solving many problems that scientists who were dedicated to these problems for many decades couldn't solve. But these techniques could solve simply because they could scale. They could deal with a lot of variables easily and work out. So like I promised, I'm going to skip the Chief Data Officer stuff. And I want to talk about some of the things that lead a lot of these organizations. And you'll probably see the title Chief Data Officer show up more and more and more. It's become pretty standard now in financial services. I like to brag that I am the world's first Chief Data Officer. We invented the term when Yahoo acquired my company in 2004. And now it's actually a fairly standard role with actually multiple Chief Data Officers in each bank for different divisions. So what drives all of this, right? Data is an interesting resource. It gains value exponentially when it's coalesced. And it loses it just as fast if it's fragmented. Now to you, if you live your typical daily life here in research, you don't think about this fragmentation problem. But it's a very, very evil problem, right? It's basically what prevents most companies from figuring out how to benefit from the data properly. If you're a customer of a big company, and say a bank, and you have a checking account with them, you may have a credit card with them, but they don't know that the two are one person. There's a lot of bad experiences, both positive and negative, I guess, because of the lack of this knowledge. Fusing this data from disparate sources sounds simple academically, and it is, except it's really, really hard. And if you care about data mining, newsflash, 80% of the effort in data mining has to do with getting the right data together in real life. And in real life includes scientific data investigations, includes all sorts of stuff. Just getting the right data from the different sources is a very hard problem. And notice these British spelling here of standardization. I'm getting rid of all my Z's, turning them into S's. Otherwise, people frown upon me in London. It's essential because that's actually how you simplify life. When you think about banks, when you think about hospitals, when you think about the minute you create different representations of the same thing, you seed the seeds of you sow the seeds of chaos. Right? I call it the curse of Babylon, where people start speaking different languages, and it translates to really, really costly things. Right? So I'll give you an example. Like Barclays, we have an investment bank. Investment bank creates lots of products. For each product, a product is an instrument that was created. The bank has to take capital reserves against it. Now, if they're unable on the back end to reconcile that these 16 different products are really the same, they're just being called different things by different divisions, they have to reserve 16 times the capital. That's real cost, real money that has to get reserved as a risk mitigator. Data governance and policy, that's very big in banking and other industries that are becoming highly regulated, and I think everything regarding data will become eventually highly regulated from a consumer privacy perspective. Worrying about encryption and masking. You hear a lot about data leaks. That's also another hard problem. How do you ever make sure? People, by the way, spend billions of dollars a year trying to secure what's called the middleware. Right? What's middleware? Probably for your life at the university, middleware doesn't exist. You don't even know it's out there. But it's basically the stuff that's between the application and the stores. And that's really hard to do, right? Trying to catch that, and that's where most people sort of break in and figure out how to penetrate, etc. The real solution sounds, again, theoretically simple, practically has proven to be very elusive. Why isn't data, sensitive data, encrypted whenever it's at rest? You never have to store it unencrypted. I've actually done that in my first startup out of Microsoft. But most companies to this date haven't been able to implement something like that. I'm going to skip the other two because they're less relevant here. Big data, you guys know this. It's a term that became very popular when applied to a mix of structured and unstructured data. And it basically applies to whenever you break sort of the boundaries of what a normal relational database system can handle. And while it can handle a lot, it can't handle things like free-form text. It can't handle images really well. It doesn't understand video. It doesn't understand all sorts of data that we call unstructured. And I'll talk about this a lot more, that unstructured data is everywhere. So the above leads to messy situations, and people use the term data scientist for people who actually know how to navigate their way here. And I think it's a very apt term, right? Because in these things, I call them data expeditions. Whenever you go in, you're really doing a discovery expedition. You don't really know what you're going to find. You think you're going to find one thing, you find another thing. But it's sometimes, often very useful. So that term, data scientist, is very apt. And by the way, if you don't know it, it is the one technical position in that gets the highest demand anywhere in the world. Right? Now it's official. It's actually admitted by governments, by institutions. It's the hottest job you can have if you call yourself data scientist. If you search the web, you'll find a lot of people who use that label on themselves. And then the question becomes, how do you filter the real ones from the fake ones? So you may have heard about the 3 V's of big data, right? People say it's characterized by volume, just how much data, velocity, which is the least challenging, in my opinion, although it can be challenging. Velocity is the rate at which data arrives. And then the most evil of them is variety, which really is secret code for truly high-dimensional data. But if you say high-dimensional data in the real world, nobody understands what the hell you're talking about. If you say variety, they all nod their head and say, yeah, you're right. This data is, hard to understand, mix of different things. But mathematically, it really translates to just high-dimensional. In databases, what that translates to lots of things that we call blobs and clobs. Anybody know what a blob is? Binary large objects. What's a clob? Character large object. So, sounds weird, huh? Character large object. It's another name for a document. That's what the relational database people like to call a document. And a lot of the queries, the standard queries, that require you to write something in SQL, don't work in a lot of these areas because they don't know how to parse what's inside these things, and the queries themselves are very hard to express. We'll talk about examples of these. So let me use an example from Yahoo for a second, just to show you what we mean by big data. This is something called we used to call it the Yahoo DNA. It's just basically for every user of Yahoo, there's a long stream of these dots. They used to be binary bits, now they're scores that tell us, the likelihood they live in an area, interested in sports, what interest they have in certain items, etc. So imagine now for 600-700 million users, you have these 2,000-3,000 variables. Sounds like a lot, but wait, it gets worse, right? So how the data really, and this is big, right? This is, 700 million by 2,000-3,000, right? So you think that's big. But it gets a lot bigger, right? You've heard of something called LinkedIn, which can tell you a heck of a lot more about this user, not only a lot more about their own profession, but who they associate with, what people say about them. You've heard about Google. You can conduct web searches on these individuals, and you'll find out all sorts of other interesting things about the places they work, the places they shop, some of the places they vacation, etc. People heard of Facebook? You can actually infer a hell of a lot. And in fact, I had a project 2 years ago in a startup company we did called Blue Kangaroo, where I had a couple of interns from France, and their summer project was, can you tell me, because you've heard about Twitter, and my intuition was Twitter is probably pretty good about telling whether you're interested in certain commercial preferences. This company is all about finding the right offers at the right time. But can you go to my social graph in Facebook and figure out what I'm interested in commercially? And my hypothesis was no, or that the signal is very weak. And the truth was yes. And the signal was very strong, which is surprising, right? I'm one of the early users of Facebook. I used it, when it first came out because I was at Yahoo, and at one point we were looking at buying them, so I used it for a while. I connected to a few people, and I expressed a few likes. So when I gave these interns the data, and I expected they're going to come back with some very stale information. Instead, they came up with a very good commercial profile of me. And how did they get that? From data that I thought was pretty stale and old. And how do you think they got that? Any guesses?
Your friends?
Yes. Not just my friends, but my friends' likes are very powerful indicators. I don't like too many things. I just don't say it on Facebook. But apparently my friends do. And it says a lot about you, right? YouTube and Flickr. YouTube now is huge, actually, including in search. It's one of the biggest search engine optimization areas. This is all ignoring the standard stuff like meta tags, all the stuff people stuff into their web pages to tell you information about context. And we're going to come back to talk about context. And then there's blogs, publications, etc. So now, take a simple thing. The people affiliated with the CSE department. right? In no time, I could write a small crawler that goes to these different sources, all of them are free, and come back to you with a big data set that you wouldn't know what to do with. Literally, what would you do with it? How would you handle it? How would you model it? How do you get value out of it? So that's the challenge. And by the way, the distinction for this reason between big data and data is fast disappearing, because you can take any traditional data set, overlay it with all these other sources, and you've got yourself a big data problem on your hands. And very quickly you find out that, okay, for most of these sources, I don't know what to do. I don't know how to traverse a social graph. I don't know how to do other things with it. I ignore it. And that's what happens most of the time. Another sort of hidden thing, if you hear about all of this, the biggest driver here is text. Right, so this is no secret, but you can do image search on Google, right? And is it good? Pretty good. Does it understand anything in the image? Not at all, right? It's looking at text, anchor text, associated text surrounding it. So most of the big data problems today, most of the drivers are text. MapReduce, we're going to come back and talk about in a second, which was used by Google in the early days and is used by all the search companies nowadays to analyze all sorts of data, all the way from, I have the box up there, IT log and security. IT logs, information, IT departments, right? They have logs. You know what is the hottest data analytics company out there today? Splunk. Ever heard of the term Splunk? Right? That's a recent IPO, very, very highly valued. Probably one of the earliest data analytics out there to IPO. And all they do, what they started with, is helping IT departments understand the logs that come out of the different applications. That's how big this stuff is, right? So, reality check. Let's say you're a company. And you say, okay, great, big data, blah, blah, blah. What do I care about? What are people saying about me on social media? Is it positive? Is it negative? Sentiment analysis, right? And I borrowed this, so what's the answer? I borrowed this graph a couple of years ago from someone else. And here's an answer. Here's a visualization of people are saying about you in Twitter. Great. How useful is that? Right? It's nice, right? And you can actually do 3D and you can navigate it. But then what does it tell you about what's happening with your company and how people are reacting to a certain campaign, etc.? So then you ask another question. Well, surely there's all sorts of companies that will help me figure out what the heck is going on. And the answer is yes. This is also 2 years old about. And it's scary. I haven't updated it. I should, actually. I haven't had the time. This lists a whole bunch of companies, right? And it's impossible to track. All of them offering you ways to sort of go after getting signal out of that data, that big data that's available to you, about your company, about the sentiment, etc. And the point of this is it's very, very, very confusing. If you're sitting in a business, what's the answer? What do you do? Who do you talk to, right? Those are hard problems. So what about on the technology front? What are people asking themselves? What's the big questions here? Right? To Hadoop or not to Hadoop? Heard of Hadoop? Hadoop is an open source project that will help you instantiate a grid of computers that helps you do things like MapReduce easily. MapReduce is just a way of taking a simple operation, parallelizing it. Scatter gather is the old term for it in high performance computing. But the question is, it's a big deal, right? Everybody is using Hadoop. Everybody wants to use Hadoop. And there's a whole movement out there. If you're not using it, it's probably a good thing to learn, especially if you want to call yourself a data scientist. And the focus, amazingly, is not about MapReduce. We're going to get back to the focus in a second. MapReduce is really, what became very popular because Google used it. And if you have to make a copy of the entire web every day and then index it and re-index it, you probably need something like MapReduce. Most other applications don't need it. So many people end up spending a lot of money on the infrastructure unwisely. Here's different areas where Hadoop is used. and we're going to run out of time. I'll leave the slides behind. And here's the vocabulary that you see in this space, right? So on your right-hand side, there's Hadoop, there's Pig, there's Hive, Hippie, Mahout, and all sorts of terms that are built on top of this. And there's, anybody know who Hortonworks is? Cloudera, MapR. So these are essentially the Red Hat equivalents for Linux in the world of Hadoop. These are the companies that offer supported versions of open source. And there's a lot. And on the left here, I've listed some of the stuff that shows up in data mining, not as big as what's happening on the compute front right now. And this is what's happening in the world of databases, right? So you've heard of SQL, relational, and NoSQL, the non-relational world. So NoSQL could mean NoSQL, or it could mean not only SQL. But anyway, you keep going here. Now, these are all technical terms. And trust me, I'm having trouble keeping up. Right? And this is supposed to be what I do for a living. So the point is, it's a highly evolving space, very, very, very confusing. And for business people, definitely a need for simplification. What do you use when? What technology works what? Where? How? Etc. So what is the biggest driver for Hadoop demand in the enterprise? What do you think it is? Why are people so fascinated with this grid that lets you do MapReduce? What do you think would be the driver?
Other people using it.
Other people using it. That's actually a good one. The biggest economic driver is storage. So one of the things that Hadoop did right is it said you can take commodity stores and you can basically do high-performance queries on top of them. Now, if you live in this world, there are public companies, one is called Teradata, for example, where a terabyte costs you about $100,000. In the UK, it costs about 100,000 pounds. For some reason, dollars and pounds, they pay 60% more there. On the low end, if you were to buy something for your home, no, not your home, maybe your office, you're at 1,000 terabytes. For home, you're probably at 200-300, right? So Hadoop can get you this high-performance stuff at about $3,000 a terabyte. And that's really the biggest driver of all of this stuff. So what's happening is people are abandoning wholesale the whole infrastructure that was developed around, Oracle, databases, data management, all that stuff is going down the drain because they need the cheaper storage. And why? Because storage has been explosive. And this is creating a huge gap. This is why you then need a data scientist, because what the hell do I do with this grid? How do I make it work, etc. Okay. And there's built-in, good compression, etc. So there's good stuff happening in Hadoop that makes it cool. All right. So the fourth V in big data, in my opinion, velocity, variety, and volume, is value. And to get value, you want to understand the context. Is the content happy, serious, informative? What does it mean to me? You want to understand the community sentiment. Is the emotion positive, negative? You want to understand the customer intent. This is the biggest thing that Google does. They figure out you're trying to buy something as opposed to maintain something, as opposed to get rid of something. The answers to your queries would be completely different, right? Same query, by the way. So these, understanding the context is huge. It helps you address a lot of applications. And I think I'm going to skip this one here. These are different application areas for analytics in particular. We'll come back to it at the end. But let me spend a minute on understanding context. So who do you think is the company that is best at understanding context on the web? I point you to a random web page, and they tell me what it's all about. Google. Why? Why does Google have to bother to understand?
AdWords.
Yeah, for ads. So here's an old example. I stopped changing it. For a while I used to change, and then Google would change on me. So, body parts delivered to Michigan home. This is an older article. What ad would you serve? What ad would you serve?
Cedar cleaning software.
This is a real example.
Organ deletion.
Look, you may laugh, but it's home, it's delivery, all sorts of stuff, parts, right? This is actually our state of the art. This is sad. This is the sad commentary on the human existence, I guess. This is the best we can do, right? And again, nothing to say against Google, by the way, we're continuously improving this, right? So, you know, is this damaging to the brand? If you're an advertiser, do you want to put your ad here? Is it positive? All right, Marius. Violence continues in Greece as rioters firebomb buildings. What ad do we show here?
Home Depot.
Home Depot? Oh, home violence? Is that what it is? No. No. Take a mini vacation. Again, a Google ad, right? And again, this is we're talking serious economics here. This is $50 billion a year in revenue, right? This is a big advertising business. The advertising business is much bigger than that, right? So again, there's also the totally irrelevant stuff that you find everywhere. We're not going to spend much time on it. So I was an advisor to a company, technically I still am, that sort of does this in depth, for example, where they actually try to study deeper, and this is, you know, I would say PhD thesis number one here, is can you do context at a deeper level, better, and offer it as a service. So, for example, caffeine, they can understand this article is positive about caffeine, not negative. So it's probably okay to show that ad there. Right? Nail gun. Nail gun, that's what the ad with Google would show, right? But nail gun here is really about programming in Java, right? So the keywords that come up with something like Netseer, Java Development Kit, some Java programmers. And if you're using these to guide the ads, you would show a completely different ad than one that just responds to the shallow analysis, right? All I'm saying here, it's a real problem and it's a big deal. And I know I need to wrap up to leave some time for questions before I run to the airport. So probably not going to have time for this case study. I joined the board of this company recently, and I sort of stopped joining boards. It's an open source. They do data mining software. And when my first reaction was, oh my God, another data mining tools company. Who needs another data mining tools company, right? Until they started talking to me and they said, you know, we've got all these customers, and we have 10,000 downloads a month. So let me repeat this. This is what got me to join this company's board. 10,000 downloads a month. I didn't realize there were that many data miners on the planet. Because to use the software, to use RapidMiner, you have to have a serious data mining task. And they talk technically, right? You gotta know what an SVM is, you gotta know, they try to make it simple. 10,000 a month, right? A lot of them from universities, about half from universities, but the rest are from a lot of companies. And in fact, they got noticed. This is, in the world of business, this is the magic quadrant from Gartner, right, where they list different companies, and sure enough, there's RapidMiner. So I wanted to go through a fraud detection case study here, but I think we don't have time because I really want to do some Q&A here and talk about the bigger topics. The idea here is sort of, the work done to do sort of this fraud detection. What's unique about this case study was done by people who aren't really specialists in data mining. So for them, it's a proof that somebody who doesn't have deep knowledge can actually use these tools and use it usefully to detect fraud, find out where it's supposed to go, etc. So I'm going to skip it, but I'll leave the slides if you're interested, and maybe on a future conference we can go deeper. I'm going to wrap up with a few comments. And I apologize for the late start. But really what's happening, what's the theme? I'm saying the old data storage, old data analysis regimes are collapsing. They're collapsing quickly. If you don't have the capabilities of dealing with big data, of the variety that comes with this variety of documents and other sort of unstructured data, you're probably not going to be very useful for very long. And the good news is there are tools out there, and it's just a question of putting them together. I'm going to skip sort of some of the learnings here at Yahoo. The biggest lessons learned, and this is working for you if you're aspiring to be a data scientist or want to relabel yourself or your resume, there's a lot more data than talent. And companies, all companies in almost all industries, are now desperately looking for these data scientists, for people who know what to do with data. And hopefully this talk gave you an idea of why, right? Of the fact that I could take a simple employee database and quickly overlay it with other sources and get some data that I don't know what to do with. Let me finally end up with a couple of observations. That simple is very powerful. And I use these examples because they're a bit humbling, right? So this is an example from Yahoo Mail. We were working with them in 2005, trying to figure out, 2006, trying to figure out how to help them reduce churn, right? When you first open a Yahoo account, you're not too attached to it, you haven't shared it with your friends, so the churn rate is very high. Primarily because people open it because it's like a spam account, right? You're trying to sell a car, you open a Yahoo account, you sell the car, you close it. You never use it again, actually, you don't close it. So, something weird happened. I classify this as stupid data tricks, but it is very humbling to me, right? So I don't understand why, but the person dealing with the data for that department came to me and said, we just noticed this in our data. Whenever people are reading mail, they read news. And they came up with this wild idea saying, this is from the mail group, saying, well, why don't we add this news preview module when you first log into email? Now, just adding this little module, previewing the news, reduced the churn by something like 40%. Stupid data trick. I don't know the explanation. I don't understand the causality. It just works. And it works so well that actually almost all news email readers today have some kind of news preview module in them, if you ever wondered why, right? Here's another one that was humbling to me. We worked with Nordstrom. This is way back with my first startup after Microsoft. And they had a pretty enlightened marketing manager, a lady called Julie Bornstein. And we were offering, web analytics and data warehousing and, selling all this hard stuff. And she's saying, well, can you answer a simple question for me, right? What is it that people are looking for and not finding on my website? Again, not something I would have thought about up front, but from a business perspective, very smart, indeed. Like if somebody comes and searches and not find, is it because my search engine doesn't work, or is it because I don't have the stuff? So people were searching for belly button rings at that time. And Nordstrom didn't have belly button rings. They didn't stock with belly button rings. So why? And the interesting question is, Julie said why, went and researched it and came back and said, we have a print campaign, and it's really about selling underwear and bathing suits, I think. But the models were wearing belly button rings. I think maybe this was the fashion then. What's amazing to me is she started stocking these belly button rings and selling $400 belly button rings on the website. And then suddenly all the Nordstrom stores offline started stocking and selling them. Right? Again, discovering this sort of hidden demand without knowing it. So with that, I probably need to leave a few minutes for questions before I run away. Was there a slide here I wanted to share? Probably not. Maybe I told Marius I was going to share my slide of 2007 saying, what are the challenges, technical and pragmatic, in data mining? And to me, I have a whole talk around this. None of them has really been addressed satisfactorily, which is pretty scary. And that's probably a good slide to finish on. So let's do some questions, and I apologize, I have to run to the airport. I would have loved to be here the rest of the day. I planned for yesterday. Yeah.
Yeah. So I have two questions. One is, what do you think are the career path for big data, scientists for a graduate student? And then the second question is, what are the best skills to have if you're entering the big data job market?
Okay. The career path, I mean, I don't know what the career path other than the position is in very, very high demand. And you can get a pretty high salary doing it. And also have a lot of fun. And probably deal with some of the more interesting problems in any organization, right? Because you're probably going to wind up with the people who are doing sort of bleeding edge, driving edge. So it's a great way to learn what an organization is all about, whether it's a bank or a telco or a retailer or an insurance company, etc. The skills, and this is why I'm encouraged to hear that the university is thinking about creating a program here, and they started with the undergraduate, and I think it's perfect for a master's track. The skills is a mix, right? You have to have, the hardest person for me to hire is finding somebody who understands statistics, has had a little bit of experience dealing with data mining challenges and problems. So, my son, who's not here this morning because I guess he has finals tomorrow, but he's taken a statistics course in data mining. And last night over dinner, we were like debating because they gave them a pretty hard problem, which is hard to do for a prediction problem to decide who's going to go for a loan, I think. But to me, the fact that he's going through that exercise is extremely valuable because that actually forces him to go through the real tough thinking, not what are the algorithms. Because he tried, 16 different ones in R, and they all didn't work, right? So now the real question is, why? And what do I need to do about the representation of this problem? And how do I employ the right transformations, or how do I augment it, and how do I partition it, etc. And that's where all the action is, right? So having enough, getting yourself through either an internship or through some of these projects, enough experience to get that intuition. That look, I can look at a problem, and I can, very quickly figure out what transformations I need to do to get it to the right representation where it becomes solvable by some of these algorithms. So I think it's a mix, and this is why I think it's essential. It's meaningless to do data mining without working on real problems. And the real problems can be with industry. That would be my preference because there's a lot of dollars there. But they can also be with government. They can also be in science. When I started my career, they can be in umpteen different areas. People have, highly specialized scientists have the same challenges and issues with dealing with big data that, your person in a retailer has. Yeah.
I'm from the data archive here, ICPSR, and we've been really concerned with addressing disclosure risk issues, data confidentiality issues. And I'm wondering what your view is in terms of what the industry is moving towards, in terms of concerns and how they're handling it.
Yeah, very good question and very, very tough question. I think my comment on sort of data privacy in particular, it's my philosophy is it's a policy issue, not a technology issue. So many people get themselves in trouble in saying it's technology and we got to find a technology solution for this problem, right? What is the analogy I use? In fact, I use this in my days at Yahoo in a testimony with Congress. What is the most dangerous weapon out there that has mass adoption? Hint, Detroit is very related to it. Cars, right? An automobile, you're driving 2 tons of steel, and in an instant you could change your mind and decide you want to drive on the sidewalk and cause havoc. You could go on the wrong side of the highway, cause havoc. You could kill instantly, whether it's people in your car or in other cars. Yet it's well governed and well adopted because we have the right policies that say, you have to go through the training, you have to have a license, and if you break any of the laws, we slap you, and we slap you hard, right? So I think that's where it should be heading, that we need these very clear policies, right? And at least in my attempts to do startups that involve consumer data, which is a very sensitive area, the one mechanism we found that is very, very defensible is to have consumer opt-in, to have a very clear, very simple opt-in that says, yes, I want you to know this about me because it's part of you delivering a service, right? So the analogy I have is frequent flyer miles, an apt analogy for me who's trying to get to the airplane by. So you know, if I get to Delta now and they don't have my number, I'm going to go out of my way to make sure they have my number, right? So I'm telling them, please track me. And if I'm traveling with my kids, I'll say, also track my little kids here, and here's their numbers, right? Why? Because they need the tracking as part of delivering the service. Sure, they're using it for marketing purposes. Sure, they're doing evil stuff with it. But I've decided to say, go ahead and use it. So I think it's about, you know, the right policies, the right protections, and the insistence on opt-in. So the EU, for example, is probably more evolved than the US is along insisting on this opt-in thing, as opposed to in the US. There's a whole bunch of industries in advertising that can do a hell of a lot of spying on you without your opt-in or knowledge. Great question. One last question, and then I'll run. Yeah.
So, can you say a little bit about the relationship between big data and the current conventional ways of collecting data? For example, you know, surveys and randomized controlled trials, and you know, where traditionally we use them to make conclusions about what is representative, and you know, or estimating certain parameters of the population, whereas big data has all kinds of biases associated with that.
Absolutely.
Can you talk about the interplay and how one comes together?
It's a very sad story there. I mean, I think it's a clear story of throwing the baby with the bathwater. There's a lot of great work that had to do with, and for good reasons, from a long time ago, and you know, carefully finding the right population, modeling biases, all sorts of good stuff that really got thrown away. And people are sort of forging away, doing analyses, finding good stuff, and moving on. So today the balance isn't at the right place. I think we will get back there. You know, as soon as you get into the finer details of, say, you know, you want to target the right ad, or you want to understand the right intent and all of that, when you get down and you slice that highly dimensional space very quickly, you will wind up with small sample problems. And you will wind up with the same old questions. Today, I think people are just fascinated enough that they can get something out, that they're forging ahead and using it, and building, you know, industries that work fine with rough approximations. It is an annoying world, right? Advertising shouldn't be as annoying as it is, but for some reason we tolerate it for now. And I think it's another series of PhD theses here that can address really deep issues there in terms of how to do it right. Because if you do it right, you know, Google showed up out of nowhere. Of course, Facebook showed up out of nowhere. All they had was a little, you know, slightly better mousetrap. There is a lot of room for many, many better mousetraps in this industry. That's why I'm excited to see sort of a program on data science here where you actually get people with enough skills and maybe get the right graduate students working on the right problems, and a lot of good stuff can happen. It's a very starved area for talent, especially talent that understands statistics. All right, I apologize. I have to rush to the airport, but I do come back to Michigan frequently, and the slides are available, and I'm happy to elaborate some other time.
Thank you, Sam.
Thank you.